Many things that humans do, from generating electricity to producing goods to using gas-powered vehicles and many more, produces over 30 million tons of CO2 per year. So, if we want to achieve the EU's goal of net zero by 2050, we're going to have to make a lot of changes, which could be pretty challenging. So, we could use positive CO2 emissions to help bridge the gap to a more sustainable future. For example, like in direct air capture, an air contractor, which is like a large fan, pulls air through a plastic filter with potassium hydroxide flowing down it. Then the CO2 bonds to the potassium hydroxide. The CO2 can be reused for other things, which is pretty similar to what I've built, where I built a box that I can make CO2 inside of, and with a fan, I can bond the CO2 to potassium hydroxide. So to build it, I first 3D printed the edges, the corners, and the fan mount with black ABS. And then to hold them together, I 3D printed red clips in PETG. Then for a solid base, I taped a piece of cardboard on the bottom and wrapped the box in cellophane. Then to make the CO2, I used a mixture of vinegar and baking soda to make CO2 inside of the box. And then, to measure the amount of CO2 inside the box, I used a CO2 monitor, and the amount of CO2 was around 838 parts per million. Then, as a control, I also measured the amount of CO2 outside of the box, which was 629 parts per million. Now, for what makes carbon capture, I actually captured the CO2. I plugged in the 12-volt power supply and turned on the 90mm fan. And then, after squirting the potassium hydroxide for a few minutes, the CO2 started bonding to the potassium hydroxide. And then, the amount of CO2 inside the box dropped to 432 parts per million. So, during this project, I set 3 main goals. I wanted to efficiently use the potassium hydroxide, as that was one of the most expensive parts, which wasn't very successful, as a squirt bottle propulsed the potassium hydroxide everywhere, and not all of it was used to capture CO2. In the future, I could use a mist nozzle to better target the spray of the potassium hydroxide. I also set the goal to better understand direct air capture to help me in my future projects, which was very successful, as I now understand how direct air capture works and why it's not fully used to completely revolutionize our sustainability. And I also set the third goal to keep the costs pretty low, as the main goal in carbon capture is to capture as much CO2 as possible with the lowest cost. So although I wasn't very efficient on my usage of potassium hydroxide, I did save a lot of cost by 3D printing the parts, as that was cheaper than using PVC pipes or aluminum extrusions to make the frame, but injection molding could still be cheaper in the future. So I really hope that you enjoyed this video, and if you wouldn't mind, please make sure to hit the subscribe button so you don't miss my next projects. Thank you.